All right, hello everyone. Let's get this party started. So today, let's see what we want to talk about. I guess I should start off with announcements as usual. So let's do that. Homework one. Whoops. Homework one is due tonight, right? I think the only regular due date that you've had. Really? Okay, good. I see that I'm broadcasting the sound. Barely. Okay, let me listen to my own stream then. Okay. I think it's fine. Okay. Yeah, so it was due Friday, but I sent out an announcement with an extension until tonight. So tonight is the night. Okay. Okay. So, I mean, I can always turn up my own volume just a little bit more, but okay, I'll do that. I don't want to, the only reason why I keep it where it is so it doesn't spike. Lab 1 was due Friday, last Friday. And Lab 2 is going to be due this Friday. And so remember, so labs are the different thing. I don't release them in Discord. I don't really release them on Blackboard. You must go to your lab section, and your TA will give you the link. So this is an open play to encourage lab attendance, so that you hopefully go. I heard that there was, I don't know, I heard that there was a significant number of people who might not have submitted Lab 1. That is not good, but we can work through that part. I'm sure everybody's just getting used to how the system is going to work. So, yeah, you must go to your lab section. Your TA will give you the link, and then it's due on Friday just because labs are all throughout the week. Basically, you can make an argument that, like, okay, why is it due on Friday? And the answer is, like, I think that most of the labs should take between 30 and 45 minutes. The reason why I know this is because that's the amount of time it used to take when they were in person. And I did write a new Lab 1, but Lab 2 is basically identical to the previous labs that were given in person. So it should only take 30 to 45 minutes. So for those of you who have discussions on Wednesday, Thursday, Friday, make sure that you get your, well, I guess no one has discussion on Friday, but for those of you who have discussions on Wednesday and Thursday, make sure that you get your lab assignments done by Friday. Okay, and then homework 2 was released. And I think that's just about it. What else do I want to say about anything else that I need to announce? I mean, I think the lab stuff is the most. Can you do homework 1 on the terminal of your Mac? I guess, yeah, probably. I mean, technically you can do anything from terminal for the class. You don't need PyCharm, but it's always nice to have. Okay, so yep, homework 1 due tonight, lab 1 due last Friday, lab 2 due this Friday, and you must go to your thing. The other thing to say is that I have a kind of beta check-in feature working for lab attendance. So lab attendance, labs are 10 points each. Do I have a rough estimate on when homework grades will be up? Yes, I do. I have a rough estimate. So here's the thing about oh yeah, that's another thing I wanted to talk about. So okay, so for lab attendance, labs are 10 points. Attendance, so 8 points for the assignment. 2 points for attendance. So at the beginning of your lab section, when your TA tells you to do this, you can run the check-in command, and there's a space here. And then you should get a DM from the bot that says that you've checked in once. And then when your TA is, when your TA is finished, you go check in again. They'll run a command and it'll say second check-in is allowed. And then you run check-in again. And then once you get your 2, right, that means that you've checked in at the start of the lab session and you have checked in once during it. Are comments needed for print functions? No. We type that in the text chat of your lab session. Yes, in the like text channel of the lab section, like lab 42, for instance. Nope. So I haven't talked at all about what kind of comments are required, and so I will talk about that when I get to it. But no, comments. So, okay, I'll just say it now. Why don't I just say it now? Comments. So here's my general rule for comments. Yeah, I mean, you weren't going to lose points if you did more comments than you needed to do, but let me just say the general rule is this. If it is obvious, then you write no comment. Okay? So what are the things that I think are obvious? Print statements, input statements, most if statements, as long as they're short. Now, if you have some really long if statements, so like non-obvious things are like long if, for, while statements, weird computations, etc. So most code falls into this bracket where you don't need a comment. The only things that you should really ever comment are things where it's like, if I come back in 2 days, well, since almost everything in homework 1 falls into this category, I mean, you could have commented the calculation if you wanted to. Again, we're not checking for comments in homework 1 because I hadn't. Remember, the rule in general is that if I haven't said anything about the thing yet, then there's nothing to be said about it. So, like, I know that it's all in the coding standards, right? The coding standards are very long and very complete, but if I haven't said anything about it yet, then it's kind of like, yes, they would generally fall under the weird calculations, so I agree that the equations would probably go in here. But if you didn't comment them, it's probably fine, and the reason is because they were given in like the homework documentation. So the way I tend to think about comments is like, if it's obvious enough to where if you put the code down for a week and you come back and you read the code, are you going to understand it? If the answer is yes, right? Yes, I'm going to understand what I've just written a week ago. Then you can leave it uncommented. If you know that you or the next programmer, like, is going to answer no to that question, like they're going to say, hey, I don't understand what that weird calculation is, or if there's some weird formula in your code that you don't want the next programmer to just be like, well, that's a weird calculation and probably wrong, so delete, right? If it's actually doing the right thing, and then you might want to leave a comment. And so that's kind of the general rule. So, I mean, I comment the lecture code pretty heavily, but when I'm actually writing my own code, I write almost no inline comments. If the thing that I'm writing is if it's very non-obvious, then I might write myself a comment. But you should always think, like, is there a way to move your code from the non-obvious category to the obvious category? And then you can... What about spaces? Do we need to know that? I don't know what you need to know about spaces. I mean, so, like, there's rules in PEP 8 that say, like, okay, I think, well, you don't even know what a function is yet, right? Technically, we haven't got to that yet, so you don't have to implement anything. I know my camera's doing some weird, funky shit right now, but I meant stuff. Sorry. Come on, camera. You can do it. I might even have to turn myself off. Sorry, everybody. I forget that I'm, like, not just in my room by myself. So anyway, okay. Well, I am actually in my room by myself, but that's a different story. So, okay, let's get back to the course material and less about the kind of stuff that I usually say. Yeah, so don't worry about spacing too much yet. The only rule for spacing is that spaces should be between operators. So, for instance, actually, you know what? I'm not even going to do it here. I'm just going to do it in the pie charm, because it'll be more obvious there. Okay, let's change the font size up. So, for instance, this is var equals 3. So this is okay, right? This is the standard PEP 8 convention for spacing of things. You notice that there are spaces between operators and spaces between the equal sign and, well, I guess equal sign is an assignment operator, so I could have just said and variables. So, so the thing to avoid, and you see that PEP 8 doesn't like this. It's telling me, you know, missing white space around around this, and if I hit, at least on Windows, if I hit Control plus Alt plus L, then it actually reformats it for me, but I'm gonna try to leave this in there. So, yeah, so basically, that's the only real rule you need to know for spacing right now. And it's not gonna be, so, I am not someone who thinks that, like, coding standard rules need to be enforced as strongly as, for instance, correctness of code. But I do think that this is definitely more readable than this, especially if you have, like, a bunch of variables going on here. It is nice to just put some free spaces in here. It doesn't hurt anything, and it just makes your code a little bit more spaced out, a little bit more readable. So anyway, I think that's about all I really want to say about that for now. My goodness, my camera is glitching. I think I might turn my camera off, because it might be the USB is just not happy, but I don't know. I don't know. Yeah, it's really glitching. I'll tell you what, I'll turn it off so that you don't have to watch it flicker. Okay. All right, so now let's actually begin coding for the day. So, I'm sorry that you can't watch my face. I think it tends to build a little bit more sense of like that there's another person on the other side of this rather than just a voice coming out of nowhere. But I think at this point you know what my face looks like vaguely. And if it's glitching like that, it's gonna distract people. Okay. So, now that I've done all of that, let's get back into conditions. So, let me pull up, let's see here. Or actually, maybe I think if you present, it opens a new window. Yes. So, I just want to go over the stuff that we went over last time. So, this is basically from Lecture 3. And, if you want to know where these are, they're on the blackboard under lecture materials, I think it's called. Anyway, course materials. And yeah, all my lectures for basically the whole semester are up there. Yep. So the one operation that I didn't really discuss last time, so we talked about plus, we talked about minus, times, divide. So there's two different divisions, and that's one thing I should definitely say. So what are the two different divisions? There is one division which is floating point division. So basically the idea here is that 17 divided by 5 is going to be 3.4. Whereas there is actually an explicit integer division. So this double divide sign is integer division. And so basically 17 divided by 5 in that case is just going to be 3. So let me just show you some examples of that. So like for instance, if I did 22 divided by 5 versus 22 divided by 5, right? And of course now you're thinking to yourself, well, that's the same thing more or less. Well, oh, wrong lecture. Let's run the correct file. There we go. So in this case, this prints out 4 versus 4.4, right? And so the idea here is basically just that there's that double divide spits out ints rounded, well, I'll say ints rounded down basically, and single divide spits out floats, even if the thing divides evenly, right? I think, so for instance, like 15 divided by 3, well, I mean, truncation is the same as rounding down, right? It forces, like, 5.9 gets rounded down to 5, so that's the same as truncation, really. So you see that here, even though, so does that work with two floats? No, I wouldn't think it would, right? So let's see if it does. I mean, I think it should break, because integer division should require that ints be put in. Okay, so it works. Cool. I guess, so does that just calculate 3.2 times 4 is 12.8, and if we add on another 3.2, we get 16. Okay, so apparently what this does is it just computes the largest whole number that for which, like, 3.2 times that whole number, right? 15.4 equals this plus some, like, remainder. The remainder is between that and 3.2. Basically, yeah, you could do that too. Oh yeah, and then you reminded me because I think you had the question about when is homework 0 grading going to be done. So that's the last announcement that I really want to make for the course, at least today. And so basically the thing to remember about grading this semester. So grading. You would think that we could automate the grading for this class. And last year I did a lot to work to automate all the grading for this class. Does mod function work with floats? The answer is actually yes, and I'll show that in just a second. But for grading, it's basically all done manually. So when you submit an assignment, so here's you submitting an assignment, right? Homework 0, for instance. The thing is that your TA, they actually have to look at your homework 0 to grade it. Now you might think, well, that's stupid. We could automate the grading for homework 0. Yes, we could. But that's basically the only assignment that we could automate in that way. So I used it as a TA training for getting used to the grading system. And so that's why we're actually also manually grading the homework 0. So basically every assignment, right, is going to go through this process. So the TAs, being humans, they get, you get a week to do the assignment. They're going to get at least a week to grade the assignment. So your homework 0 grade should be coming out in the next few days. So next few days, your lab should be coming out, lab 1 should be coming out. Basically, your lab 1 should always be graded by the time you submit lab 2, et cetera, et cetera. But, yeah, so that's basically how grading is going to work in this class. So, I have definitely worked on making an automated system to do this, where instead of a TA, you'd have some kind of bleep blorp robot. This is a robot. But the problem is that robots don't believe in partial credit, really. So, if your code doesn't work perfectly, or if you have an error in it, or if its output is almost right but not perfectly right, and that would affect, I think, something around, when we get to the projects, it'll affect at least 50 or 60% of people, right? It'll probably affect 60% of people who have some small problem with your code. If a robot graded your project, your grade would be 20%, right? Because you'd pass something like 20% of the tests that an automated system would do. Whereas if a TA grades your assignment, so this is the robot, and if the TA grades your assignment, you can get a B, right? Because you might have actually done most of the things that you needed to do, but you just have a bug that's preventing a lot of the tests from working. So that's the explanation of grading in this class. So basically, that's why TAs are doing it. Again, I've tried to figure out faster systems. The problem is that there are not faster systems that you would like more. I promise you, if we made a faster system with a robot, there would be 5 to 10 times as much hatred for that system, because your grades would drop pretty precipitously. Unless, of course, you do everything perfect all the time and never make any mistakes. In that case, sure. Okay, so let's go back to integer division and mod and stuff like that. So it basically divides them and then casts to an int and then back to a float. That's kind of what this looks like it's doing. Yeah. Generally what this is doing is, if you print out, say, 7 divided by 2, right, and then 7 mod 2, for instance, then what you're going to see is that the division is going to give us the quotient, and the mod is going to give us the remainder, right? So that's basically how that works. Yeah, so it's also useful because if you see what's happened here when you use, for instance, even 15 divided by 3, and I know that put that in other places. So note that this spits out a float, not an int. And the reason why you can tell that it's a float is because you notice that at the end it spits out 5.0. It doesn't spit out 5 without, right? You see that here, 7 divided by 2 spits out 3, but no 0.0. 7 mod 2 spits out 1 and no 0.0. There's also some weird stuff that you can do with mod, at least in Python. So in Python, you can do some weird stuff with mod. So let's say that you want to take a number, let's say 5.3, and we want to mod it by 1.25. And you might think, well, that shouldn't work, because this thing needs to be an integer, right? Oh, it kind of does work. And you notice that it works because, well, it kind of works, right? So it's interesting because, well, we get round-off error, because 0.3 is actually equal to 0.29999 blah 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 blah, right? And of course there's an 8 on the end of that, where it actually should be another 9 and then go on for infinity, but it doesn't. The binary representation of 0.3 is just not possible. So at least, I should say the finite representation in binary of 0.3 is not possible. So here's the thing I'm going to say. I'm not really going to use this feature in homeworks or projects. Probably, very unlikely. It exists, but I'm not going to test you on it. The reason why is because most programming languages do not support a float mod like this. Okay, so that's what I wanted to talk about in terms of that. I wanted to go over integer division a little bit. And so now I want to go over... So here's something else I want to talk about. And so now we're going to get back. So this was just integer division. This is like a random topic that we just kind of have to throw onto the front of the course because there's not really another place for it. So there it is. Anyway, let's talk about evaluations of comparisons. So what I mean by that is, for instance, if I print out 3 is less than 5, then what's going to happen, right? So this is the same thing as like if, well, it's not quite the same, so I won't say that. But I was going to say something that's very similar. So I'm going to run this code. And so what is it going to print out when I do this? I think we have us on low latency, so you should be able to tell me what you think it's going to do. Yeah, so I think it will print true, so let's see what happens. Cool. True. Interesting. All right. So now what about if I do this? And then I have to remember my alphabet. So G comes before H in the alphabet. So I think this is going to print false. Cool. So here's one. Z is less than A. So that's also going to print false. But what about this one? That's a good question. I haven't said that word yet. So why? Yeah, so technically, you're right, it does go based on Unicode, but really more simply, it just goes based on ASCII values, at least for the, what would we say, for the letters and symbols with ASCII values. And so basically, the idea here is that every character that you can see on a screen has some kind of code that's associated with it, okay? And so I'm going to print this out and show you that it's true, and then you're going to be like, why? So if you ever want to know what the code is for a specific character, you can do this. It's called ORD, and then you must stick in a character. You can't stick in a whole string because it won't take that. But it will take a single character. At least I hope it doesn't. Let's see if it ORD hello. Let's see what it does when I do that. I'm not sure what it's going to do. Because it's supposed to take a character. Okay, let's try it. Excellent. So here you see that Z, the capital Z, right? Capital Z is a value of 90, and lowercase a is a value of 97. Oh, I should write lowercase a and lowercase. Okay, so that's interesting, right? Because capital A and lowercase a, capital B and lowercase b are different characters. And this is true in all programming languages because all programming languages they all use some form of ASCII, or if it's in some other country, they'll use Unicode or some other kind of character encoding system where the characters have to be translated into numbers. Okay, and then here we see type error ORD expected a character, but found a string of length 5. So this is bad. Okay, cool. So one thing that Python does do for you, for instance, is this. And so the question is, what does this do? Is this going to be true or false? And you're like, well, they're different types, right? So it's different types. So maybe false, but they are equal, right, as numbers. So maybe true. Right? That's kind of the thinking process that you should go through as a programmer. You're like, well, these two things are of different type, so it might be that they're not equal, but I don't know. But it seems like they should be equal, right? Because 3 should be equal to 3.0, and it is true. Oh, right, and the last thing that I wanted to say before I... so let me put the error back in. Okay. So here's a weird thing. This line of code happened here, right, after all these other print statements. But look at where the type error happened. The type error happened at the very top, right? So what's going on here, right? The type error didn't happen on the first line. Like all these other lines happened before the type error. The type error happened like, I guess, right here, and then we don't see the last line. We don't see the last true. So this has to do with the way that, like, so it's actually not happening in compile time. It's not happening in compile time. It's actually happening in runtime. And here's the weird thing about it. So basically there are two streams for output. So there are two streams for output. There is standard out. Wait, why is that? Okay. Standard out. And then there's standard error. And so basically, whenever you print something, you put it into standard out. Okay? So that's what printing does. Errors, like you see there in Python, get put into the output for standard error. And that's why they're in a different color. But here's the thing. Standard out and standard error are two different output streams. And so sometimes one of them will buffer for a while. It'll be like, okay, I'll print this, but whenever I feel like printing. And then it'll say, okay, I'll print this whenever I feel like printing. And then say it actually prints here, right? and then say it queues these other two, and then it prints them here. So what happens if this error happened right here? Let's say it happened in this line. Well, the thing is that it might be that this actually prints first. And then these two lines will print. And then, of course, once the error happens, it won't get to the rest of the code. But the point is that standard out and standard error are not completely synchronized. So that's why whenever you see an error in Python, and you say, the error must have happened exactly here, exactly at the beginning of the program, because that's where standard error, that's where this thing is written out. No, you have to look towards the end of your standard output, like the white stuff, and you have to be like, where is the last thing that actually printed out? And that's where your error happened. It didn't happen at the beginning. It happened right here. It's just that standard out, the print function basically, it just queued all this stuff up in a buffer, and then when it was ready, it dumped it all out to the screen. And so, as it turns out, standard error is just always a little faster than standard out for some reason. At least I've noticed that on multiple computers. It's just always just a little faster, probably because it doesn't get as much stuff written to it. So that's just one thing to keep in mind, is that whenever you're debugging your code, you don't look at where the error is written here. You look at where the error, where the last output is, and you say, okay, the error must have happened right after this, because it couldn't have happened. The error can't happen in here, because if the error happens in here, then none of the other print statements will run. Okay. All right. So first I'm going to now comment this out. Whoa! Ha! I didn't even know that was possible. Okay, that's better. So, okay, what's next, right? So we have all this printing stuff. Oh, sure, yeah. Okay, so let me just check and see if there's anything else that's good. The opposite of ORed is CHR, and that will convert from some integer into a character. So for instance, if you printed out like CHR65, that should print out a capital A, unless I'm not thinking hex, so yes. And if you print out like CHR97, that'll print out a lowercase a. And then there's a lot of other letters that you can print. But again, so we're not really going to use this very much this semester. But it's good to know, right? It's good to know that basically everything you see on the screen is really just some kind of encoding of a number, right? Like capital A, the computer doesn't know what capital A is. The computer knows what 65 is. And it goes and looks it up in like the little character table that it has, and it pulls out the symbol, like the printable symbol for 65, and that's what we see as capital A. And so that's how computers deal with strings, because computers really can't deal with text natively, right? They have to convert everything. Well, sure, I mean, the computer sees it all as binary, but my point is that 65 can be converted into binary, and then you can, do that way. Okay. So let's talk about some other things about if statements. So for instance, let's say A is equal to 3 and B is equal to 0. And if I say A and B, we're going to print out A and B are true. Else not true. So here's some weird stuff that goes on when you do Python. So it's actually not that weird. It's pretty standard in most programming languages, but it's something that you have to start thinking about. So yeah, machine code is a slightly different thing that thankfully we don't really have to talk about in this class, because Python is an interpreted language, and I might talk about more about what I mean by that when we get to it, but yeah. Okay, so is this going to be true or false? And so I'm going to run it. And it says A and B are not true. So what if I change this to 5? A and B are true. So there's a weird thing that goes on in Python. And I don't know why I'm calling it weird. It's not that weird. It's not that weird. When you evaluate a variable for true or falseness, it works like this. Let me see if I have a good slide for it. I probably do somewhere. Maybe in lecture 4. Here it is. So here's the evaluation of true and false. So basically, here's how it works. And you're right about that, yes. So in Python, what kind of things evaluate to true? And this is in lecture 4. What kind of things evaluate to true and what things evaluate to false? And so here are the things that evaluate to true and false. Anything except 0 as an integer is going to evaluate to true. Anything except 0 here is going to evaluate to true for a float. So numbers, as long as the numbers are not 0, right? That's the only thing that it requires. If the number is not 0, then it's true. If the number is 0, then it's false. So you might ask, well, what about negative numbers? Negative numbers are not 0, so they are true. And I'll show you that in just a second. What other kinds of things are not false? 0.001, right? That's a floating point number. It's very close to 0. It is true, right? Python, the only thing that Python asks when you ask, is a variable true or false, is it 0 or not? So 0.0 is false, yes. So any non-empty string is true. And I'll show you some examples of that. And the null string. And so by null string, I'm kind of stealing from C++. You can call it the null string, the empty string, whatever you want to call it. And you notice here I've denoted it either with single little tick marks or quotation marks, right? So it doesn't matter which one it is. These both evaluate to false. In fact, these two things are actually equal in the underlying Python, so it doesn't care about the symbol you use to denote the string. And then the keyword none is never true. It's always false. And I just always throw in none whenever I'm talking about Python, mainly because it's good to know. So, okay, so for instance, if I wanted to say if true and false, right, we're going to print happy, right? So is this going to print out happy or not? Well, PyCharm already knows, right? PyCharm says this code is unreachable. So why is this code unreachable? Because if you do true and false, you have to remember back to the truth table. What is the truth table for true and false? The truth table for true and false, is false, right? So this will never print, since true and false is false, right? So this will not print out, right? So it doesn't print happy. Okay, but what if we do something like if the empty string, or I know what to do, if not the empty string, print, here we are, that is strange. So this is going to work, and the reason why is because the empty string, remember, empty string is false, not false is true, so not empty string is true, and that evaluates. Okay? What other kinds of things should we talk about? So for instance, if we have if say 0.0, print float 0 is true, right? So no, it's not quite the same, no. So you note here that if 0.0 we print float 0 is true, but float 0 is true never printed, so float 0 is false. So what is the difference between if A is equal to B versus if A and B? So print A is true and B is true. So I'm saying what the thing is, but let me actually just assign them to be values. So, what is the difference? And so the difference here is that if I assign A is equal to B is equal to 0 like this, then what you're going to see here is that A and B are both 0. So A is false and B is false. So this statement can't print, right? But 0 is equal to 0, so A is equal to B, right? So A is equal to B, but we also note that, this statement did not print. So that's essentially the difference. Okay. And I will say that this is kind of a standard thing in most programming languages. Let me just say that, basically here, if I do variables like this, since they're ints, it's going to not assign references. But if they are references, then yes to your question. But we haven't talked about references versus values yet because we haven't talked about lists yet, and so I'm going to leave that off for now. Okay, so here it says none is false, right? And you might be wondering, what the heck is none? Basically, none in Python is just a way for us, when we get more complicated objects, at first you can always set them just to be none, or for instance, return values from functions if the function is, if you want to return nothing when something goes wrong or whatever, or when the input doesn't produce correct output, you can always just return an NONE object. As it turns out, the none object is kind of interesting because if you print out the type of it, it is a none type. And there is exactly one none type object in existence, and that is none. So you can't actually make any more none types. But anyway, we shouldn't talk too much about none yet. We should talk about other things. Okay. So I think what I want to do now is talk about what do I want to talk about? I think it's about time to talk about nesting. So before I talk about nesting, let me just do a little reminder of syntax. So basically, whenever you create an if statement, what you need to do is you always have to have if, and then let me set some condition equals true, right? If the condition. And so what are the things you need? You need the if part. You need whatever the condition is, which is probably not just going to be condition. And then you need this colon. right? So if you don't have the colon, it will definitely not work, and it will give you some kind of syntax error. So if you, for instance, if you do something like this, it's going to say invalid syntax. Now you notice that here, actually nothing ran, and so this is an example of a compile time error, right? And the reason why we can tell it's a compile time error is because look at how none of the code from before it executed. It looked through the entire file first, and it said, not only is this code going to produce an error, this code is going to just simply not even, it doesn't even make sense to me as code. And so I'm not going to even compile your file. And so you need the colon there. And then you need this tab. Now, so we see that if the condition is true, then it will print out A. We need all the code in the if statement to be tabbed in by 1. The reason why we need this is because unlike in C++ or in like JavaScript or Java or basically a huge number of other languages which use the curly braces, for instance, like, let's see, do I have some code here? Yeah, so here's some C++ code. And here you see an if statement. Basically, the idea of this if statement is that it's basically the same. It's just asking if this variable here is less than the variable called pivot, then it'll execute this code. But I don't need to tab this in C++. This will work just fine. I can even do something horrible like this, and C++ will be fine. I can do this. I can do all manner of really horrible looking things in C++, and it will compile. The reason why is because these curly braces provide like a syntactic feature that allows the programming language to know that everything inside the curly braces is at the next level. In Python, we don't have the curly braces, and there's really nothing that replaces them. Well, almost nothing that replaces them. What replaces them is the tab. And so you have to tab your code in. So as it turns out, Python is not whitespace insensitive. And what that means is that your whitespace, like the tabs in your code, matter. So for instance, if I did something like this, I mean, you see that PyCharm is already yelling at me, but I'm going to ignore it. Here it says indentation error, unexpected indent. So you see that this is also a syntax error, right? It just won't let us do it. Because at this level of, the thing is that there's no if statement here. There's no if statement here. So it's looking for everything to be at the same level of tab. So basically everything must be at the same level of tabbied. Yes. Okay. Well, that's all true. None of that is false, except now we're going to talk about nesting. So what is nesting? So for instance, let's say that we have I hope not. Okay, so let's say that we have two inputs. Let's say we do person input, what is your name? And then we say if person equals, I don't know, Robert, then what we're going to do is say I don't know, what kind of things would you ask someone named Robert? I guess you would ask like input do you golf, Robert? And then if the person is named something else, and I don't know, you could ask them, well, let's say you say, and so basically here what we would do is we'd say, if the person if yes, no, then what we're saying is that the person's name is Robert and yes, no is equal to yes. So then we're like, hello, Robert the golfer. And then we can say, I don't know, else. You know, hello, Robert, who has no opinion of golf, right? And so, yeah, in this case, yes, no is just a variable. So I guess my name is going to be Robert, because I want to actually execute this. But then let's see what happens. So for instance, if my name is Robert, then do I golf? I don't golf, and I can't even lie about it. So there we go. There we go, right? And so what we see is that this phenomenon here, this process is called nesting, which means you have one if statement outside, right? And on the inside, you have another if statement to deal with another thing that can happen. So basically what happened here is you have one branch, and inside of that branch, you have another branch, right? So you can either go down the yes route, or you can go down the, technically it's just else or the no route, or whatever you want to call it. So, yeah, so that's basically how to deal with that. Is, yes, so equals is case sensitive. So for instance, if I did this, I said, my name is Robert, and I golf, right? So you notice here I typed in capital letters, and it didn't like that because it said, hello, Robert, who has no opinion of golf. So clearly yes is not equal to yes. So there is a way to deal with that, and what you can do is you are allowed to use the dot lower method. Technically, you could also use the dot upper method. Or you could do that, but then what if someone types in capital Y, lowercase e, lowercase s, right? The thing is that there are, There are 8 combinations, I guess, because you could type in lowercase y, capital E, lowercase s, or all kinds of different things. Usually just smashing the thing down with dot lower is pretty good. But let me also say that dot lower doesn't actually modify the original string, so if I print out yes, no again, let me just show you what happens. And of course I am Robert again, and then Y-E-S. And so you see that even though yes, no dot lower equals lowercase yes, when you print out yes, no, it hasn't changed. And so yes, no dot lower is going to give you back the lowercase version of the string, but it doesn't actually modify the string. The reason for that is actually that strings are immutable, but we'll talk about that. What about lowercase Robert? So you notice that I don't have any kind of dot lower or dot upper on this. So if I just typed in, then it skips this whole if statement, right? Okay, so let's do something like this. Oh, here's a good example of, here's a good example of an if statement. So if we have if x is not equal to 0, then we can have, so for instance, we're going to say x equals int input tell me int. And so what I'm going to do here is I'm going to say if fall. Oh, no. I'm just going to tab. Good boy. You cannot divide by 0. So yeah, probably. I can do a lot of things. I'll just use this example. Actually, I think maybe I'll make the example a little bit better. Maybe I'll just use this. So here's an example of some code that what it's going to do is, the first thing it's going to do is it's going to input an integer. So for instance here, tell me an integer. Now if I enter 0 here, it's just going to say you can't divide by 0, right? And what if I tell it, say 5, and I give it and so now we're going to give it another integer. I'm going to give it 10. So now 10 divided by 5 is equal to 2, so that is double. But then if I give it, say, something else, so I say, tell me an int 3, tell me another int 9, not double, right? So you see what this is doing here. What this is doing is, if the thing is not equal to 0, then it allows us to go into this block of code here. If it is 0, then... If it is 0, then it says you can't divide by 0. And let me just say why you can't divide by 0. Well, so you notice here, Python has a special error for that called zero division error. So don't divide by 0. Now, you might think, well, why can't we just... No, there's... it's always too complicated to include division by 0, so I would say just don't do it. Say no to division by 0. So whenever you're about to divide two numbers, it's usually safe to check whether the denominator is 0, and that will make it so that your code doesn't crash most of the time. So if we tell it another int, so let's say 15, and let's tell it another int 7, so it's not double, but let's tell it, I don't know, what's the last one? 32, 16, oh wait, crap, other way around. 16, 32, there we go, double. So, so you see how this logic works, right? What it does is it first goes through this if statement, and then it goes through this if statement. Once it checks that if x is not equal to 0. And the reason why you want to make sure that is true is because if it's not true, then you're going to end up doing some zero division. So, cool. Okay. So let me do one more example of nesting. So for instance, let's say s is equal to input enter string, and let's say if s is equal to, and I know I'm just stealing this right out of my own slides, but I don't care because they're my slides. If s is equal to integer, then x is going to be equal to int input enter an integer. And so we can say if x mod 2 is equal to 0, then we print something. What is that something? What does x mod 2 being 0 tell us? So x mod 2 being 0 tells us something very specific. I guess else we print not something. And then else we can say x is equal to float, input, enter float. And then we say if x is bigger than 0, we can print out positive, else print non-positive, I guess, right? So, okay, so yeah, this is evenness, and this is not even. I guess not even is also equal to odd, but whatever. So let's tell it an int. So remember the int is up here, so let's just do 5 and 5, so it's not double. Enter a string. So remember, 0 is an even number, right? 0 is an even number. So let's enter integer here. And so now it says let's enter an integer, so let's put in 3. And so, right, so, yeah, non-positive technically means like negative or 0, right? So let's tell it an int, 5, 10, that is double. Now let's enter a float. Let's enter the float. So the float we're going to enter is negative 2.713 for no particular reason. And so now it's going to print out non-positive. Cool. So I think the moral of the story here of all of this is that, oh, yes, okay. The moral of the story is that you can stick if statements inside of if statements. But you notice that what you have to do when you do that is you have to basically indent everything one more level. So everything here is inside of this if statement. Everything here is inside of this else. Everything here is inside of just this if statement. Everything here, of course, there's only one line, but I don't care, is inside of this else. Yeah, so that's the point about nesting. So you do sometimes need to do this. There's ways to avoid it, but whatever. So here's a common thing that people do that I'm going to actually talk about. So here's a common pitfall. Let's have s equals input tell me string. And so what we're going to do is we're going to say if s is equal to hello or goodbye. Well, that's not going to work. Print hi or bye. Right? So, and then I guess we'll have an else statement. Print neither. So let's do this. So we want an int, so we'll enter 5, 10, I guess it's double again. ASDF is going to give us a float. There we go, positive. Okay, so now tell me a string. So what's the limit to, oh, okay. I mean, I feel like the limit should be about 3 for the vast majority of your project. So if you have an if statement within an if statement within an if statement, and you're going to add another one, then you might want to think to yourself, like, am I doing this the best way? So I think that's the general, I mean, there's no hard and fast rule. If you have 10 nested if statements, like an if statement inside of an if statement inside of an if statement inside of an if statement, all the way down, that's either the most complex code I've ever seen, or it's just wrong. So it will always print out hi or bye. Now, why is it always going to print out hi or bye? So what if I type in ASDF for this, right? So s is not equal to hello, and s is not equal to goodbye, but it prints out hi or bye. So why? Why does it do this? Why? Yeah, it's always true, but why? Yeah, good point. Good point. So remember what I said about order of operations, right? So it always goes like this. Arithmetic happens first, and then comparison operators like this equal sign happens, and then the final thing that happens is logic. Okay, so logic happens after the equal sign. So here, this s is going to compare itself to hello, and it might be a true or false. And then it's going to say or goodbye, but it doesn't see the s equals. All it sees is the string value from goodbye. So basically, here's how to fix this. That's how to do it. Okay? So it might seem a little duplicative, it might seem a little inefficient, but remember that you need to do s equals hello or s equals goodbye, because if you don't do the s equals on both sides, this s equals is going to evaluate, and this will become true or false, and then it's just going to look at the true or false value of goodbye, and it's not going to compare it to s. So, and that's just because comparisons happen before logic. So now, if we run it again, so 5, enter string ASDF to, okay, now tell me a string. The string is going to be peace. And so peace is neither. So now this works, right? And so you'll see some kind of similar stuff. I think one of the most common errors that people commit is when you read this kind of thing in English, you think to yourself like, oh, if x, so let's set x equals to 3, right? If x is equal to 2 or 3, print x is 2 or 3. And so a lot of people, I see this a huge amount in the beginning. I see this a huge amount in the beginning of programming, where what we find is that people kind of forget the order of operations. So you read this as basically x is equal to 2 or x is equal to 3, but it's actually not that, right? So if I change it to, so basically, like in order to fix it, so this is broken, and the fixed version is the same thing as the last example. So, and it makes a lot of sense when you write this down. You're thinking to yourself, oh, it's going to check if x is equal to 2 or 3, but it's actually not going to do that. So, okay, so that's one common pitfall to avoid. What else do I have to talk about? I think I've actually kind of almost made up the time. I might almost be able to end a lecture on time. Isn't that crazy? I mean, that's literally the most wild statement I've ever made in my life. Okay, so I have 2 more minutes of your time. So in those 2 minutes, let me try to make them valuable. What I will say is that all of this stuff is in my lecture notes on the course page, and so I encourage you to go through those lecture notes, and I encourage you to kind of figure stuff out for yourself and try to do homework 2. Oh, constants. Well, the good news is I don't think you really need any constants for homework 2, so we won't talk about. I'll talk about them next time. We'll do constants next time. I mean, there's a lot. So the constants fall into the category of like coding standards stuff that I kind of distribute over multiple lectures, because if we just had one lecture where I only talked about coding standards, I don't think anyone would watch it. Well, constants are a specific type of variable, but I don't want to go into it because that will take definitely more than 1 minute. Okay, I think that's it for today. I will post this. In fact, what I will do is I will post this to the GitHub right now. Git commit, lecture 4 on conditions, committed, git repository push. So, so this should be up on the internet now. Do you guys, here's a question. Do you actually look at these things on the GitHub? Just curious. Okay. I was also thinking of sending out like a Google form with like a little survey. And because normally I ask these kinds of questions at the beginning of a class, but I realized I never asked it this semester because it's just not the right format. I'm wondering if you guys would fill out a survey that just talks about like what programming experience you have, what's your background, just a little bit about like who you are, so I can get a good like statistical understanding of all the people in the class. Um, I don't know. Maybe I'll even make it like an extra credit point or two. But the anyway, I would just like to know, and I usually ask, when everybody's in person. So yeah, I'll come up with something today and I'll send it out. So yeah, and I'll tell you about the results. I'll be like, okay, so this number of people have done these languages, and these number of people have no programming experience. It's really just a good way for me to like understand who I'm talking to. Because right now I'm talking to a YouTube comment stream. So anyway, I'll put something together. All right. All right. So that is really it. That is really it. Yeah, so no, I mean, it's good if you look at the GitHub, it's good if you type stuff along in PyCharm, it's good if you look at the lecture notes afterward. All of this stuff is good. All right, I'm going to talk to you later, everybody. Have a good rest of your day. Um, yeah, I'll be around on the Discord as I usually am. You know how it goes. All right, outro time.